Today we're going to talk about scientific notation. Scientific notation. So scientific notation is a method in chemistry and other science fields to represent a really large or a really small number. So let's say we have something like 0.00001. We have so many zeros and this is a really small number, but we can just simply write it as 1 times 10 to the power of -4. So this is the scientific notation form of 0.00001. So how do we convert a number into its scientific notation? Let's look at a really big number first. Let's just use 10,000 as an example. So in this number, our decimal point is at the end of the number right here. But if we want to convert it into its scientific notation form, we will have to move the decimal point to where there's only one digit in front of it, or you can say to the left of the decimal point. So in this case, we will want to move the decimal point to here, where there's only one digit in front of the decimal point. So let's just count how many places we moved. So 1, 2, 3, 4, 4 times. So we would just write this number as 1 times 10 to the power of 4. 4 is how many times we moved the decimal, and 1 is the non-zero numbers in this number. You can also see it as 1 times 10 times 10 times 10 times 10, so 4 times, and we're adding 1, 2, 3, 4, 4 zeros after the 1. What if it's something weird, such as, I don't know, let's just say 7, 5, 6, 7, 7, 8. There's no zeros in this number, but we would still just want to move the decimal point to where there's only one digit in front of the decimal point. So in this case, our decimal point is right here, and then we want to move it to here so that there's only one digit in front of the decimal point. Now we just count how many times we moved. So 1, 2, 3, 4, 5. 5 times. So in this case, we will want to write all the non-zero digits out. So we will have 7.56778 times 10 to the power of 5 because we moved the decimal point 5 times. Now I'm going to give you some numbers for you to try. Let's say the first one we have 4,780. The second one we have 59,320. And the last one, let's just say, I don't know, 7580232000. This really long number. Can you convert these to their scientific notation forms? Pause the video and try it on your own. Let's work through these together. So for the first one, our decimal point is right here, and we want to move it 1, 2, 3, 3 places, so that's right after the 4. So this number in scientific notation form would be 4.78 times 10 to the power of 3. How about the second one? Our decimal point is right here, and we want to move it to here. So 1, 2, 3, 4. 4 places. So this one will be 5.932 times 10 to the power of 4. The last one is a really huge number, but we still start from here, and let's just count how many places we have to move the decimal point. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So this number would be 7.58022 times 10 to the 9th. Now let's look at some really small numbers. I'm going to use 0.00001 as an example. So just like what we did with large numbers, the only thing that changes here is the direction that we move the decimal place. So with the large number, such as the one that we did before, we're moving the decimal place to the left. But with smaller numbers, we're moving the decimal place to the right. And we want to move it to where there's only one non-zero digit in front of the decimal point. So in this case, we will move the decimal point 1, 2, 3, 4, 5 places, and then we will write this number as 1 times 10 Instead of positive 5, we should put negative 5 for a small number. So remember, whenever we're moving the decimal point to the right, or if it's a really small number, it should always be a number times 10 to a negative exponent. So the negative exponent over here just means that you're flipping the number into a fraction. So this number, we can see it as 1 over 10 times 10 times 10 times 10 times 10, 5 times. Because when you have a negative exponent or a negative power, you're basically flipping this number. So instead of 10, you would flip it to 1 over 10 to the power of 5. So now let's try some other numbers. Let's say we have 0.003, 0.0005, and 0.000763. Pause the video and try these ones on your own. Now let's work through these together. So the first one, we're moving the decimal place 1, 2, 3, 3 places. So it should be 3 times 10 to the negative third. Remember, the exponent should always be negative for a really small number. Now the second one, so 1, 2, 3, 4. So 5 times 10 to the power of negative 4. So the last one, the decimal point is right here. And 1, 2, 3, 4. So we move the decimal place 4 times, and we're gonna get 7.63 times 10 to the power of negative 4. Just remember that whenever we move the decimal point to the left, or when the number is really large, the power on 10 should always be positive. So 10 to a positive power. But if we're moving the decimal point to the right, or if it's a really small number, the power on 10 should always be negative.